Hello students, this is the Digital Knowledge Irshad Academy with a new video of NAND Logic Gate. Before going to description, see that you have subscribed my channel and press bell icon for the next video. Coming to the introduction part, we have already discussed three logic gates, that is the AND gate, OR gate and NOT gate. They are called basic logic gates. Then are universal logic gates. They are NAND gate and NOR gate. NAND gate and NOR gates, they are economical and easy to fabricate. That is the advantage of universal logic gates. These gates, universal gates, they are used in almost in all digital logic families. Now looking at the circuit is a NAND logic gate. This is the logic function can be performed by using two switches. These switch A and switch B, battery and lamp, they are in parallel. Unlike AND gate, in AND gate these switches were connected here in series with the battery, switches and the lamp. This is one difference. The second difference is that in an AND gate the resistor was connected in the emitter circuit and we were taking the output across emitter resistance, but here the output is taken across R2 in the collector circuit. For the first combination, when both switches are open, A is open, B is open, the current is flowing from a negative terminal through the lamp, cannot flow through switches. Why? Because these both switches are open. It flows through lamp and back to the positive terminal. This is a electronic current, and the lamp glows when the both switches are open. The lamp glows. This is the first combination. When A is open, B is open, the output is 1. We can say logic 0. When A is 0, B is logic 0, the output Y is logic 1. For the second combination, let us close switch B. Alright, the current coming here, although B is closed, but A is open and therefore it cannot travel through switch A, rather it goes through lamp and the lamp lights. For the second combination, when switch B is closed, this lamp glows. For the third combination, when switch A is closed and B is open, current cannot flow through switch B, it is open, but flows through lamp and gives a light. For the third combination, when A is closed, B is open or off, the lamp is giving light, therefore is a logic 1. For the fourth combination, when switch A and B, they both are closed. Closed mean on position. The current coming here finds a path through B switch. Closed switch is just a piece of wire, flows through A and back to the battery. The current does not flow through the lamp. Why? Because it finds a easier path through piece of wire, but here it finds the resistance of the lamp. Therefore, for the fourth combination, when both A and B are closed, the output is 0, and this is complementary to AND gate truth table. The truth table for the AND gate is 0, 0, 0, 1. But in case of NAND gate, this is the opposite or inverse or reverse of this or complementary of this. This is when two inputs are given, You can give 3 inputs. For the 3 inputs, the possible combinations will be 8. For 4 inputs, the output combinations will be 16. We are going to make a truth table for 16 inputs. A and B are the inputs, and this is called invert bubble at the output. That represents a symbol for the NAND gate, and the Boolean expression for the NAND gate is y is equal to A dot B over bar, and we can omit dot, and this can be simply written as y is equal to A B whole bar, or we can say A is NANDed with B and the output is Y. That is the Boolean expression. This is also correct, and we can omit the dot, and A into B whole bar, or we say A is NANDed with B. Coming to the transistors, see, we can use transistors to perform NAND gate operation. It's called resistor transistor logic RTL. 2 inputs A and B are connected in the base circuit. T1 is a transistor T1, transistor T2. Output is taken from this point. R2 is the output resistance connected to positive VCC, and we are taking the output across R2. Let us see that for the first combination, when A is 0, B is 0, they both are reversed bias. There is no current flowing through both the resistors, and we take the output here full VCC, and this is logic 1 we are taking. For the second combination, if B, we apply a high logic voltage at B, and T2 is forward bias, but since T1 is reverse bias, the current cannot flow, and we get the output voltage here full VCC, that is logic 1. For the third combination, when we apply logic 1 voltage or a high level voltage here, T1 is forward bias, T2 is reverse bias, the current path is not complete, current cannot flow. As such, we get the output voltage from here, that is full VCC. When we apply both high logic 1 voltages at A and B, both the transistors are forward biased, and we know that when the transistors are conducting, it is just a switch, and the voltage VCC through these 2 transistors are shorted to ground, and we do not get any voltage here, that is, we get 0 voltage, and the output voltage for the NAND gate Boolean expression is y is equal to A dot B whole bar, or the dot can be omitted, and we can write y is equal to A NANDed B is equal to y. This is the correct way of expressing Boolean expression. Going to the summary points, key points of NAND logic gate. The first is NAND gate means not AND gate. AND gate followed by NOT gate produces low output when all inputs are high. That can be seen here. When both switches are closed, mean logic 1, lamp is off, the output is logic 0. When A is logic 1, B is logic 1, both transistors are forward biased, and the VC is shorted to ground, we get a 0 voltage. Or we can say when the inputs are high, the NAND gate provides low voltage in the output, low level voltage in the output. Symbol for NAND gate is similar to AND gate, but a bubble at the output. This bubble is called invert bubble. NAND gate is inverse or complementary of AND gate. NAND gate is known as the universal gate, that is, it can perform AND, NOT, or operations. We can fabricate the circuits by using only NAND gates, and then they can perform AND function, NOT function, or function. NAND is AND gate followed by NOT gate. Most commonly used logic gate is a NAND gate. It can perform other logic gate functions. A dot B is equal to Y, or A into B is equal to Y, and we will read it as A NANDed with B equals output Y. This point is most important point. This is to be kept in mind. Let us go over to summary points once again. NAND gate means NOT AND produces low output when all inputs are high. Symbol for NAND gate is similar to AND gate but a invert bubble as the output. NAND gate is inverse or complementary of AND gate, opposite of AND gate. It performs function which is opposite to AND gate. NAND gate is known as a universal gate, that is, it can perform AND gate operation, NOT gate operation, or gate operation. NAND is AND gate followed by NOT gate, most commonly used logic gate. It can perform other logic gate functions. A dot B whole bar is equal to Y. This is the Boolean expression of NAND gate. This can also be written as, we can omit dot and we can write A dot B is equal to Y whole bar. But when we are going to express, we are going to read it, we will read it as A NANDed B equals Y output. That's all. Thank you very much. In the next video, we'll discuss NOR gate.